We are now recording. Okay, so we've got just a few more rules that I want to share with you. The kind of rules you already know. So what I'm going to do, I'm going to write down three questions, and I want you to try and work out the answer. No calculators needed, because the numbers should be okay, but just work out the answer any way you want. All right, so here's the first question. Question 1 is, and question 2 is here. And question 3 is here. There you go. So there's 3 questions for you to try. Have a little think about how you go about solving those. I think the numbers are small enough that you could work out each of the numbers with the exponent, maybe. The numbers are small enough, I think. Okay, I'll start slowly with the top one, and I'm just going to show you my method. I'm going to work out each of these individually and then multiply them together. Okay, so I think over here that's going to be 8 times 4, which is 32. Okay, so I think that first one was pretty doable just by doing some number crunching. The second one, I think, 3 is 9, 27. Oh, this is 81, right, I think. And then this is 9. 81 divided by 9 is indeed 9. And then the last one, 2 times 2 times 2 is 8. Then squared, and that's 64, right? Beautiful. So not too bad. Yeah, not too bad. But of course, there does come a problem if I gave you the following questions. Right, that's going to be pretty tough to answer using our previous method. And of course, there's no need to use our previous method because there are some beautiful rules of powers or indices that apply to each of those situations 1, 2, and 3. All right. So let me just move this one down here away for now. And let's just look at this 32. So this 32 up here, actually, I can write it as a exponent or a power of 2. All right, so should we try it? 2, 4, 8, 16, 32. 2 to the 5 is 32. So the answer here could be written as 2 to the 5. The second answer for question 2, 9. Well, that can be written as 3 squared, right? And the third question, 64, can be written as 2 to the power of something. Tell the person next to you what number goes in the cloud. So what number goes in the cloud? 32. No, not 32. 2 to the 6, should we try it? 2, 4, 8, 16, 32, 64. 2 to the 6 is indeed 64. So this is 2 to the 6. Beautiful. Let's see if I can get those blinds down so you can see what's going on the screen. Huh. It's that time of the day where they don't want to work. Oh. No, they don't want to work. All right, not to worry. And so here is the magic. Are you ready? let's try do this in a, well, let me just change it to black ink. So if I have 2 squared times 2 cubed, what you can think of, this 2 squared is 2 times 2, and this 2 cubed is 2 times 2 times 2. And can you see now? It's a little bit clearer. This is 2 to the 5. So in fact, the rule is 2 to the 2 plus 3. So if we have a 2 and a 3 power here, but we have the same base, we can just add together the powers. And let's do that again now for maybe this one. I think I've changed the question a little bit. But this is 3 times 3 times 3 times 3 times 3 divided by 3 times 3. Now, anytime we have a whole bunch of multiplications, and then on the bottom and top, the times 3 here will just cancel out with the divide 3 here. The times 3 here will cancel with the divide 3 here. And can you see you've just got this left, which is 3 to the exponent 3. So if we have 2 numbers, same base, and a division, we take the 5 and the 2, and we just subtract. So this is 3 to the 5 minus 2. And the last one, what about 2 cubed squared? So inside the bracket is 2 times 2 times 2. But the squared means times it by itself. So we literally times it by itself. Can you see that that's actually 2 to the 6? So in this situation, 2 to the 3 to the 2, 2 to the power of 3, all to the power of 2, we are going to just take the base, and then we're going to multiply the exponents. So that takes us to the following 3 rules now, which we'll add to your list. Then we'll do a little bit of practice. If you have a to the exponent m, or to the power m, and you times it by a, so notice we have to have the same base number, and this is to the power of n, then the final answer will be the same base a, and we will add together the exponents. When we have maybe, let's do a b to the m divided by b to the n, this will give us b, the same base, but then we will subtract exponents. And when we have a to the m in a bracket powered up to n, then the final answer will be a, the base, and the m and the n we multiply. And because we're mathematicians, we don't need to put a times between the m and the n, because we know that the missing operation is multiplication. All right, so with those rules, why don't you get those rules written down in your whiteboard, and then get your books out, and let's get those rules down in our books, okay? So these are rules of powers or indices, and I'm going to add them to the main board on the side there, but also get the other rules down in your books. So title, rules of indices or rules of powers, and then I will add these to the sideboard, and then we will have a go. With these questions. And un momento, por favor. I'll just finish this off. Okay, so for these questions, you can leave your answer in power form. So you don't have to write the answer down as 64. It can be 2 to the power of something, all right? So have a go at those 4 questions, and then I'll put these new rules on the whiteboard at the front.